In the center of Paris, just a stone's throw from Notre Dame, there's a rather ugly tree that tells a really cool story. Because this tree, one of the oldest living beings in the capital, arrived as seeds from the Appalachian Mountains. Planted in 1601, this black locust tree has been here longer than the oldest bridge in the city, which is still called the Pont Neuf, and completed not far from here in 1607, and which was the first bridge in Paris to swap wood for stone. For this tree, the transformation also seems to have begun, as it appears to be sagging and needs to be supported by stone pillars and ropes, so bent is it under the weight of its age. But is this black locust tree really collapsing because of its old age? Because we can ask ourselves the question, isn't this tree, deep down, always new, like the bridge, in a state of perpetual construction? All around the tree, you can see what are called suckers, little clones that sprout and grow again from the roots. Some of these suckers are even kept by the city's gardeners, because if the mythical main trunk were to collapse, they could, in a way, bring it back to life by planting these suckers. But the craziest part might not even be that, because the vast majority of the branches of this tree are themselves small trees, young clones growing on the old trunk, on the old branches, and they have their own root systems, which would make their way down to the ground. Foresters call these clones and their roots. They are often accused of exhausting the mother plant and reducing its fruit production. But this negative view doesn't do justice to this crazy strategy, one among many that allows for the incredible resilience of trees. Here, in a sense, death has to wait, because there is continuity. In fact, even without referring to these vegetative reproduction strategies, a tree is made up of hundreds of meristems, buds made of stem cells, capable of producing all the organs of the tree. Leaves, flowers, stems, roots, which have been duplicating and multiplying ever since the first of these buds emerged from its seed. And in fact, each of these buds can, in theory, produce an entire tree. So should we speak of trees as individuals, or as a collective being whose individuals are closely united? In any case, a tree is, in practice, divisible. Don't try to plant your finger, it doesn't work. A worm cut in two is just a worm cut in two. Dividing an animal is killing it. Dividing a tree is multiplying it. And in a way, this strength, this particularity, is made possible by their simplicity. In an animal, you can count about 100 well-defined organs, each performing a specific function. Lungs, heart, liver, all kinds of glands, brain, nerves, tendons, and muscles. But trees only have 3 types: stems, roots, and leaves. This means that a tree doesn't really have a vital organ. All these parts are expendable, replaceable. Trees are divisible. They don't have an expiration date, a best before date, and are therefore potentially immortal. Of course, they often die from diseases, bad weather, being eaten, or crushed under their own weight. We animals are born, we live, we die, tragic, basic, simple. But for trees, in a way, it's a bit more complicated, because they never die of old age. Until their death, they keep growing and are constantly being born. In their buds as well as in their root tips, the stem cells of the meristems make the tree grow from the tips. And this happens whether the tree is 2 years old or 2,000 years old. The problem is considering these shoots as parts of the individual that produced them. Or, to put it another way, a fully fledged part of a plant colony, sharing resources and genetic codes. So, it will be difficult for you to guess, at first glance, which one is old and which one is not. Let me introduce you to Pando, a living organism weighing 6,000 tons and spreading over 43 hectares. The 47,000 trees that make up this forest are all connected by their roots and all share the same genetic code. And if we consider that this tree, the oldest in Paris, is a single individual, then Pando is too. Its age is estimated at 80,000 years. When Pando started to grow, it was crossed by saber-toothed tigers, mammoths, and groups of Neanderthal men and women. But we could also take, on the other hand, the example of this Mexican swamp cypress, which grows in the small town of Santa Maria de Tule in the state of Oaxaca. With its diameter of 42 meters, it is often considered the widest tree in the world, although it is actually the result of the merging of several distinct trunks. Is it an individual or a colony? You decide, but even if cut in half, it won't die. If you are stubborn and want to find indisputable individuals among trees, look to palm trees, which are rare and sad in the heart of Paris, but display spectacular diversity in the tropics, where there are no fewer than 2,500 different species. A large number of them consist of a single trunk produced by a single bud, a giant meristem, which gives them, when they are tall, that unique and easily recognizable silhouette. Like the earthworm or Marie Antoinette, the palm tree is an individual. A palm tree cut in half is simply a palm tree cut in half. I can already hear the botanists typing in the comments, palm trees are not trees. But as Diderot said, a word is not the thing itself, but a flash by whose light we perceive it. The problem with trees is that they're hard to fit into a category, and for good reason, because they don't belong to a specific botanical group. In other words, there are no common ancestors to all trees. This form appeared independently within several plant families over the course of evolution. So, trees are a blended family, united by the sacred bonds of definition. A narrow definition gives the name tree to plants that have a trunk, which results from continuous thickening growth. As the tree grows, its trunk gets thicker. If you cut it, you'll usually see visible rings inside. This definition excludes, for example, palm trees, for which we don't talk about a trunk but a stem, which doesn't have any rings. It also excludes dragon trees and tree ferns. The second definition, on the other hand, includes them by calling all arborescent forms trees, all plants with a long lifespan and vertical growth. Being a tree is actually a strategy for occupying space and time, taking your time to take up all the space. With two goals, to capture as much light as possible and to spread as many seeds as possible. A strategy that is riskier than it seems, because unlike annual plants, which in temperate regions grow, bloom, and bear fruit during the warm season and die when the cold arrives, they leave their seeds to ensure the survival of the species. A tree, on the other hand, can take years to bear fruit. So it has to survive several sometimes harsh winters, seasonal changes, and droughts before it can truly form its trunk and try to ensure the survival of its species. For those that manage to reach the size of a building, reproduction becomes a spectacular undertaking. Just like turtles, which have this unique trait in the animal world of becoming more and more fertile as they age. It's not really related, but I thought it was too cool not to tell you. With trees, a single large individual can produce tens or even hundreds of thousands of seeds, and this happens every year. So, we're tempted to think that most of these seeds will fall and then grow around the tree, creating an obvious problem, eventually ending up competing with its own offspring. But that's without considering the advantage that height offers. Being tall and reaching toward the sky allows the tree to get rid of and throw its offspring farther away. A technique that's popular among conifers, but also among many flowering plants, with the technical name of anemochory. So, the majority of trees, like most plants in general, begin their lives carried by air currents. Achin, umbel, samara, papus. So many ways and forms found to let their offspring, their thousands of descendants, float and drift with the wind. Maybe, if you project too much, you'll find this cruel. But in any case, it's much less cruel than zookery, which involves surrounding these defenseless little seeds with a generous layer of sweet flesh in the hope that they'll simply get eaten. But far be it from me to want to drag trees through the mud, since they're often already there, and above all, I think we owe them almost everything. Their existence gave us fire. They provided us with roofs, furniture, and boats. They feed us, heal us, reduce landslides and floods, and give us plenty of fresh air to breathe. And even, what is less known, they dramatically increase the surface area of the earth. To measure it, become for me, just for a moment and by the power of thought alone, an ant on a concrete slab. In front of you, a square meter of desert plain stretches out. Place a human being, 6 feet tall, on it. You will then have added to your ant territory about 2 square meters of additional potential surface to explore, counting the entire area of the skin that covers us. But if you now add to this scene a small oil palm tree 3 meters high, then your territory is suddenly enriched with 400 more square meters to roam. Because yes, the total surface area of a 3-meter high oil palm tree has indeed been calculated, and it is 20 times larger than the floor area of my apartment. In other words, trees wildly multiply the total surface area of the world. If you doubt it, take a 100-year-old oak tree and a month off, and have fun estimating the extent of the surface of this giant that's in contact with the air. To do this, you need to calculate the average surface area of a leaf, both sides, multiply it by the number of leaves, and then add the surface area of all the branches and the trunk. A titanic task for a gigantic result. Because unlike animals, most trees try to get as far away as possible from the sphere, which is the optimal shape to fit the maximum volume in the minimum surface area. To do this, they look for solutions in fractals, which can be seen in the structure of their branches and roots. This allows them to maximize their surface area relative to their volume and to optimize gas exchange, as well as the absorption of water and light. So, when a square kilometer of forest burns, it's actually tens of thousands of hectares of habitable surface area that, for the small animal world, go up in smoke. Deforestation makes the world much smaller than we think. So if, like me, at the beginning of the 21st century, you're afraid that the world is becoming too small for everyone, plant trees and above all, think carefully before cutting any down. An old tree will always be worth more than real estate.